Hey, my name is Prabha. I work for Microsoft Devices business. I lead the data engineering, data scientist organization. Our primary charter is to build data pipelines, sourcing the data from multiple nodes in our ecosystem, from factories and warehouses and retail centers. And Jaideep, do you want to introduce yourself?
Hey, my name is Jaideep. I'm a senior software engineer in Microsoft. I have been working for almost 8 years in Microsoft. I basically work on mostly big data technologies.
Yeah. So today is in the next few minutes, we wanted to talk about how you can leverage several data services, data platforms that are available in Microsoft Azure, one of the leading cloud platform in dealing with the big data. Right. So the agenda is to give a quick refresher on what big data is. Of course, we all know about it, but just to set the context, and we would want to motivate the problem statement with an opportunity in a retail scenario. And of course, what we will be talking about today doesn't just apply to the retail scenario, for that matter, in terms of like any sort of industry today leverages big data. So this architecture in general applies to all those scenarios. We'll talk about big data architecture, the standard best practices and guidelines in terms of how do you do batch processing versus stream processing, and how Azure solves it. I think that's going to be the primary focus of this next few minutes. And services like Azure Data Lake, Azure Data Factory, Azure HDInsight, which is the Hadoop from Microsoft platform, and also recently the new service called Azure Databricks, which is offered through Azure as well. One of the interesting things is that there are many open source services that are available through Azure as well, like for example, Kafka and Spark platforms. So we would briefly touch up on them. The breadth and the depth is so vast, so we won't be able to cover everything in this next few minutes, and we will probably spend some key services and scenarios, and we'll take it further in the next sessions later. So quick background. So we all know about, heard about how big data plays in today's businesses. In fact, every business, every company is becoming a tech company, and it is powered by the availability of the big data and also the capability to process them in big compute, which is available through the cloud platform. Volume of the data is growing day by day. In fact, it is expected in 2020 about the wide world will have about 40 zettabytes of data, which is like 40,000 exabytes. And if my calculation is correct, it's about 400 million petabyte. So in the past, only people generated structured data. We call them enterprise data. And then we had this social media bust out, and there are petabytes of data started coming from that source. And then nowadays that lots and lots of machines are generating through IoT devices and sensors. So that's the growth of data exponentially in the last several years, and it is going to continue to grow in that way. Luckily, we have the compute power to process them, analyze them, and gain insights that helps you to make decisions for your business. And similarly, velocity is something changed a bit. In the past, again, it's a structured data, mostly manually collected. Nowadays, because of the advancements in the IoT devices and sensor, now we are getting lots and lots of real-time data, and people are using that real-time data to make business decisions. So one of the key concepts is called digital twin. In any business that, for example, in a retail scenario, I want to know exactly what's my inventory in my warehouses right now, instead of looking back only the descriptive analytics that we used to do in the past. And variety is different types of data. It's not only structured, it is unstructured and semi-structured, so different types of text, audio, video. So we have the capability to ingest the data, clean them up, analyze them, and gain insights. So we want to motivate with a problem statement in the retail industry. Every business needs to understand their customers. Customer retention is the biggest problem today. And in terms of growing your sales, growing your revenue, knowing your customer and building a promotional strategy, analyzing your brand is very important. And that's where the role of a big data plays in terms of using the historical data on the customer behavior and even predicting what the customers will be doing, and based on that you change your business strategy. So that's the motivations here. To give you a little bit more specific scenarios, use cases, how retail industry leverages big data. Primarily today, if you go to any e-commerce websites, you will see recommendations. So the recommendation engines are built based on the data that we have collected so far. And it is pretty much everybody is using big data for making strategic decisions. Forecasting trends, like when you launch a new product or there is a holiday season coming up. So how do you want to make sure that your supply meets the demand? So that's forecasting accuracy is very important. And there are technologies that are available today to leverage that in delivering that. And market basket analysis, like how do you do bundling and making sure that which SKU or which product sells very well with the other one. And listening to social media. Today, you get the feedback immediately from the social media, and it is completely unstructured data. So how do you process them to make sure that you understand what your customer sentiments are, what they are liking, what they are not liking, and things like that. So we talked about some of the predicting trends and also the customer experience. So those are the key scenarios that any industry is using the big data and big compute in the retail scenario. I think the similar use cases are applicable to many other industries today. I just want to give you a brief dashboard sample, what it looks like, and Microsoft Azure has a technology called Power BI to generate them. Even people who are not that technical be able to generate these kind of reports on the fly, real time. In the past, we used to have only the descriptive analytics displayed here. For example, like what happened yesterday, what happened last week or a previous quarter. But nowadays that you start seeing a lot of real-time dashboards, and even some of the forecasting trends like predictive analytics also displayed in the dashboard. It's just the sample how the retail industry is using it. So another one. We touched upon structured, unstructured, semi-structured. Structured is primarily relational data. We all know that, RDBMS, and not many people are using RDBMS anymore. People moved on to NoSQL databases and the data types, the payloads like JSON types, and semi-structured, which are mostly social media data, images and words and PDF and things like that. So those are the major type of big data that we see today. And the challenges, there are many confusing variety of technologies available, many cloud providers, open source solutions available, and even within a same cloud provider, there are many options available. For example, within Azure, there are different technologies available, like when do I use Azure Datalake, when do I use Azure Data Analytics versus Azure HDInsight. So it depends on the scenario, depends on the use case, depends on the performance requirement, latency requirements, and things like that. So we'll be touching up on some of those things today. If you take any big data architecture, from the left, you see the different data sources, and data sources could be, it could be APIs, it could be IoT sensors, or it could be another data storage systems. Basically, like you do ETL is the terminology that we used to call. It's extract, transform, load. It's kind of morphed into ELT or ETLT nowadays, that you don't really worry about the structure of the data. So you extract, load them, and put them in the data lake, and then you can take those data from the data lake and give the schema to it and start processing or start analyzing to gain the insights. And from a batch perspective, and the streaming real time, There are technologies available such as Azure Event Hub or even Kafka for that matter, which is message brokers, and the stream processing using Spark technology for real-time analytics and real-time machine learning. And I would ask Jaideep to go into the details of what are the technologies that we have in Azure.
Okay, thank you, Prabha. So, on this example, like on this architecture, like I'm gonna take it as a retail industry as example. So in the retail industry, like if you take an example of a Target or Walmart or something like that, similar to they sell the goods to the customers, and they are not only sell the goods, they buy the goods from other customers also. Like the Target might buy the goods from Walmart and they sell it in their product, Toys R Us or something like that, and they also manufacture their own goods. So if you see okay, so in this case, like, okay, why I'm explaining these things is that so we are getting the variety of the data from the many different sources. So if you see in this architecture, one is the data sources where we collect the data. So we might be getting the structured data and unstructured data on various different formats. Like we can get a CSV files. Some customers are uploading their Excel files, or they're sending the data in the blob, or there is a relational database systems where we extract the data using the web APIs and other things. And there is another thing is like so we have a IoT sensor data coming from the different customers or manufacturing sites. They are manufacturing the products, as well as they post the data to the event hub as a events. So what, like, the main concept on this one is like collecting the data from the various different sources, how we do in the Azure. So Azure provides a capability called like services called Azure Data Factory, which is kind of like is a ETL jobs, which runs the jobs on on trigger basis and schedule basis kind of thing. So what we can do with the Azure Data Factory is that it has we can create our own pipelines pulling from the different data sources and collect in the centralized storage location. So for that one, like there is if you see here, there is a storage location. Azure provides a storage location called Datalake, which is like which is capable of storing a huge amount of the data. Is mainly purpose of the big data to serve the big data platform, and we can store data like text files, flat files, and those kind of stuff. So in this case, like, and we also have like stream analytics, which can read from the which mostly used for reading the unstructured data from the IoT hub and event hub. What, like, these are like unstructured data, means like it might be the JSON, it might be the something Excel semi-structured, or even with structured data which comes on the real time as a real-time data. Like if any event happened and it triggers in within a seconds to the, and we can push it to the data lake. So once we done with the extracting process, we collect all the files, all the data from the different sources. We store data in the we store the data in the data lake. So this is a, like, data lake is a centralized location for our centralized storage location, where we can have a multiple folder structures like created inside the data lake and put all the data coming categorize data into the subset, like it's a source information, or is the data coming from manufacturer information, or data coming from returns information, or stores info, like customer data. We can categorize them and store it to the data lake. So once we receive the data in the data lake and we categorize the data, and what we can do is that we can do the cleansing of the data. Like we can clean up the data, we can remove the duplicate data, we can remove the like we can aggregate the data in small amounts and remove the duplicates, and clean the data, and whatever the necessary columns, like we can only take the subset of the columns which can be used. That all can be done using the Azure HDInsights. So mostly, like, as I suggest you, like there is in Azure HDInsights we can create a Spark cluster, which is mostly used for big data capabilities kind of thing. Like we can run a massive big job, create a job to go to the different source information and collect the data and clean the data, removing the duplicates. So once we have a clean data, we store it data back into the data lake, which is our centralized storage location, in a different folder. We call it, like, when we in the terms, like industry terms, they call it as the raw data is which we receive directly from the event like factories and those kind of stuff are any from the sources, and where we called as a gold data is something like which is already cleaned up, remove the duplicates and those kind of stuff. So once we received the data in the gold folder, then we can create another like using the HDInsight transformation. HDInsight, we can transform the data, we can do the aggregates, we can do the analytics on the data, and just like whatever we want to, like on the weekly basis on reports, like whatever based upon our reports, what the data we want to transform, we can combine the data from two different sources and put it in like single visualization format, and then store it back into the data lake again. So in this process, we basically the process which is nothing like it brings all the data and combined everything into, and and kept it to the, this is like a transformation in the ETL, like it's a building a facts and the big facts in the ETL, like because the logic heavy lifting is happening in this process.
So the entire orchestration is done by the Data Factory.
Yes, the entire orchestration, the Azure provides like in the Azure Data Factory, we can create a pipelines which can be run, and the pipelines can be dependency. Once we read the data from the raw, immediately trigger the gold pipelines, and then trigger the process pipelines, like which is stored the data in the cooked folder. When we call in the term like it's a cooked, nothing but is a transformed data. From there, like once we have a transformed data, then we can use the data to analyze the, mostly like the data science teams and other teams, like they read the transform data and try to see how they try to understand the data, how to either they may use the machine learning or Databricks and some sample queries they write and see how do I see the trend is going on, those kind of stuff. Or else like same thing, we can use HDInsights also, and the Azure also provides a capabilities called like Azure Data Warehouse is nothing but a SQL. It's you can convert the data in very structured format and put it in the Azure Data Lake, Azure Data Warehouse, and run like whatever the queries and see how the trends and looks like. And once you analyze the data, and then we use the Microsoft Power BI reports or Excel reports to show the visual reports to the based upon the analyzed data. So that's what in earlier slides Prabha was showing the Power BI reports where we see the data. All the data, the cooking is happening on the back end of the HDInsights or Databricks or a data warehouse, and it's only the aggregated data we push to the Power BI and just create a visual dashboards, so that it's easy for the users to see the trend, how it's going on, those kind of stuff. So all these capabilities are provided by the Azure, and there are a lot of other capabilities, and like there are like other, like instead of HDInsights, like people use the directly ADW and Databricks. So, but when we see this kind of thing, like the heavy lifting, like it's a scalability, like if you today, like you are a small business, you're starting with a small, you have only like 2 customers, like you have 10 customers, you can spin up a small data lake, which you can pay on a go. When the data grows, you can pay on the size, or else you have fixed Databricks data lake kind of thing. And Data Factory is like orchestration. You can schedule a pipeline when how many pipelines you want to do. And the HDInsights is like nothing but you can is a big cluster. You can start with the 4 nodes, and then when your business keep on growing, then you can increase your nodes in the cluster. That's where the Azure is like very good at. Okay, you are a very small business, your initial stages of your business, you can only spin up with the 4 clusters, you can only pay $100 per day or something like that. And then when your business grows, you can increase that to and pay the $1,000 when your business grows and your needs grows. Okay.
So what kind of skill set needed in addition to what we see here?
So mostly like if you have a C# background, or like you have a Scala kind of thing, and the Spark, to write a Spark job, either you can write a Spark jobs in like using a Scala or Hive. Hive is nothing but is like a simple like a SQL query language, structure query language, and the Spark is nothing but like is a programming language. It's simple programming language. You don't need to know you don't need to be expert in the programming language. You can simply use the data frames. We call it as data frames in the Spark, which reads the data into the files or RDTs. Either you can store in the RDT or data sets and data frames. These are 3 different kinds used in the Spark. So we read the data from the files, and just we aggregate the data aggregate the data on whatever the columns you want to do and those kind of stuff, and we store it in the data lake bag. So it's a very straightforward, it's very simple to implement this kind of thing. If you like, it's everything. Like if you see in the data lake, we centralize we follow the standard. We bring all the data from the different sources, we store it in the text files or Parquet files or JSON in the standardized format. So that when we read the transformations, like it would be easy, like, okay, we read this data from the different sources in the same format and write it to the same and same, like, you know, once we transform, we write it to the text files and whatever thing. So these all capabilities are provided in Azure. You don't need to go anywhere out to buy any subscriptions or something like that. Once you subscribe to the Azure, you can create all this thing using the Azure without going to anywhere else. And mostly it's a UI driven. Like it's just like as a click, as a multiple clicks, you can spin up a HDInsight cluster and or data lake or something like that. I'll show you a sample example how to create a data lake in the next slide. So once you log into the so this is the Azure UI. If you go to the Azure UI, this is the Azure UI. You can see all the services provided. There are a bunch of the services. If you go to the all resources, you can see. If you try to add a new resources, for example, you can see all this, like it's a web storage, storage accounting, networking, compute, and databases and those kind of stuff. If you go to, if you know the services what you want, you can type like data lake here. So it will show the data lake 1 gen 1. So you can create a data lake and giving the data lake start free, like you can create a data lake using this subscription and here. Okay, so like this, like you can create a APIs, you can easily deploy, you can create a SQL databases, you can create a Cosmos DB, virtual machines. All these are provided in Azure. So there are like around 200 services or 300 services provided in the Azure currently, and they are still building a new services every day. Like this is my experience. Every day I log into the Azure, I see something new, and there's like you can see the data lake Gen 1, data lake Gen 2. In the HDInsights also, right now when I started, it was only the creating the Spark cluster, but now I can see the IO caching feature in the Spark cluster, which is Spark. Currently, this HDInsight supports the Spark 2.3, and they added like IO caching feature in the in the Spark 2.3, which gives some more flexibility to like process the large amount of the data. So when you go to the presentation, like this is the flow how we can this is like one of the example, like architecture, like how we can do the end-to-end using the Azure services. Like so in the next thing, like I want to cover is that what is a different type of architecture we use. Okay, so one of the architecture we call like is called one of the architecture is a Lambda architecture, which is nothing but the Lambda architecture is nothing but it has both a batch layer and the speed layer. So something like, so to run the business, there are like some scenarios we need to know the data. We need to know the data and results immediately, very fast. For example, like customer sends a customer order, the information, and we need to check like how the item is available in the store, how many customers are ordering, and and we just need to detect that from the existing inventory in the store. That should be happening in the real time. That is called speed layer, like whatever, or a stream layer, whatever. And the other things, when it comes to the batch layer, it's like I want to see the daily aggregate reports and how many items we sold, how much money we made, or like what is the trend going on. Those kind of stuff is a nightly jobs or hourly jobs, or it can be like daily jobs and those kind of stuff. Though even hourly jobs are considered as a batch layer in this case. So the stream layer, we read the data as a events, and we use like something like a stream analytics. There are different technologies like stream analytics, and we push the data directly to the Power BI, so that the factory managers or shop managers who can directly see the trend, how it's going on, those how it's performing for every hourly basis. When it comes to the batch layer, we wait for like it's an hourly job. We combine the data from the stream, as well as like we combine the data from our backend. Like, okay, we want to tie up like how many shipping we are receiving next day and how many we sold today. Oh, okay. So for example, like, okay, we sold almost like everything, and with nothing this is available in our inventory, and it takes like 2 days, like next shipping is happening on next 2 days. So that kind of analysis, like it can be done in the batch thing. So we don't need to do hurry anything, like, okay, just like, so the thing is that why we need to use like streaming in some scenarios, why need to be why not everything can be done in the batch is a streaming like this. It depends on the cost. Okay, how much you are affordable like putting everything in the streaming, and how much like you in the batch. If it's, for example, like the customers are coming to store and they don't find the product and going, so that if you're running the batch jobs, you don't even know until like 2 hours of what is happening and those kind of stuff. So this is like in the Lambda architecture, we have like combination of both streaming and batching is the same. We can implement with the same Azure technologies is in the HDInsights, and for the streaming we can use like a speed layer, we can use the stream analytics and those kind of stuff, but the end of the reports are displayed in the Power BI. Okay, so next one is like this is a trending architecture. Like this is the people are going like Kappa Architecture, which is more real-time data. Like it's a nothing but it's the same like a Lambda architecture, but people are saying like it's mostly they don't want to wait for the batches of the keep the data volume is going, the needs are growing, so everything they want to do it in a very everything they need to do in the very speed where like fast and those kind of stuff. So so in this case, like as we discussed, like what is why the batch processing is important. Like batch processing is nothing but like so as I explained is so we see batch processing is runs the jobs in every hourly or twice a day or thrice a day, and maybe in the weekly and those kind of stuff, to combine the data from the various different sources and to analyze the data, mostly for use for analyze the data, how the trends are going on, or how where my inventory is sufficient for next 1 week, or how long it can sustain, and what is the top sellers. Like for example, if the Transform movie released and the toys of the Transformer, or the Jurassic Park movie release, the toys of the Jurassic Park are like is hot cakes in the market, and they are selling like anything. So to understand what is exactly happening in my store, that kind of things can be done in the batch processing. So using the batch processing, like we can get the data from the blob storages. You can use the data, we can get the data from the other data lakes. Usually in the like any big industry, they have multiple data lakes, or else like they can have a huge big data lake that like multiple data lake. Finance, they have a separate data lake, and they have a manufacturing, they have a separate data lake. So this is like to how to secure the data. The reason for having the multiple data is the secure data. Like financial people doesn't see the manufacturing data, manufacturing data shouldn't see the financial data and those kind of stuff. So in that case, like we read the data from the multiple data lakes or SQL DBs or Cosmos DBs, and then use batch processing, usually like use a Spark or Hive or use SQL or Pig, which are the technology we can be used in the batch processing and those kind of stuff. For analyzing, like the analyst who can then once we process the data, we push it to the one of the ADW or still store in the data lake, or else like or any other SQL servers or something like that. So they where the analyst can perform their so analysis on the data and like look at how it's happening, what is the useful metrics, and those will be reported in the data lake. So orchestration is already covered. Like like everything can be done in the Data Factory. Data Factory provides like scheduling the jobs on a trigger basis, time basis. Like you want to run a job on every 1 hour, you can schedule it as 1 hour, or it can be trigger basis. Like in some source has uploaded the data, immediately when you see the file, you can trigger the file. And it's not only that capability Data Factory provides, it also provides a dependency. Like you run the first job, oh, first job is finished, then I need to run the second job, then I need to run the third job, or else like multiple jobs. Once we can trigger and based upon the signals. So that kind of thing is basically like covered in the batch processing. So real-time processing is nothing but like I can see this is like it's a mostly the event. For example, right, in the store, in the manufacturing store, they want to monitor the temperature in the room, how it's happening, and those kind of stuff. If temperature goes down, they need to turn on the ACs and those kind of stuff to analyze that one, how much efficiently the manufacturer is working on in the factories and those kind of stuff. So they kept the IoT sensors in every room or every place, or where are in the line where they're manufacturing and those kind of stuff. So every second, every sub-second, they receive the events like, okay, this for example, like temperature is the best example to measure the temperature on what basis, like when to turn on the coolers and those kind of stuff. So they send the temperature on every sub-second and see, and they also see that, okay, how many people are there, is if the factory is empty, they can reduce the temperature or something like that. So to combine the data from all the sensors, that is a real-time data, and they want to understand the trend, like, on the minute basis, this minute is 70 and this minute is going down immediately, like 69. So they want to understand the trend and see and analyze the data, see how efficiently they can operate the manufacturing factories or sites. And the real-time data can also be like in customer cases, like they can get the feeds from the Twitter or else like Facebook and those kind of stuff, like see how the customer is reacting to the products. So what exactly the customer needs. That is also considered as a real-time data. Like, okay, so we subscribe to the feeds and just like Twitter APIs, and just try to use the hashtag to find out like what exactly, like, if in the hashtag and then subscribe to that events and read all the events and combine like and do some machine learning kind of things, like how to analyze like what the customer is customer is thinking about the products and those kind of stuff. That can be done in the those kind of thing can be done in the real-time implementation. For that, Azure provides the event hubs, IoTs, and external like Kafka, and the processing can be happened using the Stream Analytics, Storm, or Spark streaming. Spark provides a streaming capabilities, like it can store the there's a feature called in the windowing in the Spark, where we can, is the times the last 24 hours I hold the events in memory and just try to if new event receives, and you don't need to go and get the data from the data lake or somewhere, you just store in the memory, and it's very fast to see how the what the like aggregate the data and push it back to the SQL server or whatever, like HDInsight, like data lake and those kind of stuff. So this is like mostly used for the stream and in real-time streaming. So this is one of the like architecture diagram, like this is what I explained, like, okay, we have a data source coming from one event hub, data source coming from the multiple event hub, and then we use the stream analytics and we can put it in the Cosmos DBs and then generate a Power BI dashboards. This is like mostly used in the stream real-time data and those kind of stuff. Okay, so the next one is like, this is another architecture diagram, like where we can use, instead of, so the Azure provides like not only the HDInsights, it has the capabilities to build a Databricks cluster. Databricks cluster is much more efficient and like use it's as advanced technology in the like compared to the Spark. Like it can Spark, when the Spark, what is like, you can have a fixed nodes, you can either reduce the nodes or increase the nodes on the fixed time. But Databricks is like you can create a nodes on demand. Like for example, right, earlier I mentioned you can create a Spark cluster with the 4 nodes. Your business grows, you need to increase it to the 10 nodes. But are you using all the 10 nodes in the for 24/7? No, it's not. Then the Databricks is a best example where it can automatically spin up the nodes, reduce the nodes when it's not, and it controls the cost much better. So that's only the difference between the Databricks and the Spark, but you can still execute the same Spark jobs in the Databricks, and you can create, instead of Data Factory, like there is a scheduling mechanism also available in the Databricks. You can spin up the jobs and run the jobs automatically. So that's the next thing which in the data, like compared to the Azure and Databricks. And if you go into the next, like, yeah, so this is all like we can the thing is that everything can be done in the Azure. We don't need to go anywhere out, or like we can just create an Azure subscription and just pay the cost on the demand and those kind of stuff. Okay, going back to Prabha, like,
Yeah, so this is very comprehensive services that are available in Azure, right from sourcing the data, staging the data, cleansing the data, and analyzing it, and gain insights and provide the data to multiple downstream things such as like doing data science and machine learning, or even just reporting to your Power BI executive dashboards and things like that. As I said, like it's a very huge in terms of depth and the breadth. And I hope this few minutes gave you good information about what are the different techniques and technologies available and the best practices in terms of batch versus stream. And at this point, I'd like to take any questions you might have.
Prabha, this is Paul. I've messaged one over on Cosmos DB. If you have a chance to address that, you may have addressed it as well.
Yeah, so Cosmos DB is not just only for streaming data.
Yeah.
Cosmos DB, you can store, it's a key value pair data set that, pretty much used in most of the caching scenarios, or you can store JSON payloads, or you can store graph databases. Like basically you have different nodes and the connections between the nodes in a relationship that you may not easily see it in a relational database. It's a different types of data storage techniques that is available. It's one of the industry leading storage for graphs, key value pair, and JSON payloads, documents to store.
Yeah. There's a limitation in the Cosmos DB, like you can only store the data for 90 days of the period and those kind of stuff. When it comes to the question is like when it comes to the data warehouse, like is a typical like a SQL, is a SQL DB, like some you can create a facts and dimensions and process put the data in the data warehouse. And the another capability of the data warehouse is that the cable, like it provides a huge cluster to do the transformations. That's only the difference, like this.
Yeah. So the next question is, what's the difference between capabilities of Spark and Databricks, as they are both used for analytics?
Yes. So as I mentioned earlier, like Spark and Databricks are similarly like same thing. You can create a Spark Spark job and you execute in the Spark as well as the Databricks. The main difference is that Databricks provides a much more capabilities like scaling the clusters and those kind of stuff. As I mentioned in the like Spark, you need to define the clusters before you run the jobs and those kind of stuff. Like if you want to scale, like you can increase or decrease, but it takes certain amount of the time, and you cannot do it on the fly. You need to prepare for that one and do it. When it Databricks, there's a feature called as an on-demand cluster. Like when you trigger a job, it automatically creates a clusters based upon its needs, and then once the processing is done, it restarts the cluster. So it effectively managed in the cost point of view is the Databricks is very good compared to the Spark cluster.
Yeah, so it's again like if you look back and look at the technology, Spark is open source that came from Berkeley. Azure has a analytics engine called HDInsight, which is basically the HDFS file system Hadoop shell that you can create a Spark cluster with the HDFS context, and you get to manage that more, versus Databricks is like managed service. So it takes care of a lot of pain in terms of managing the nodes and upscaling and downscaling, and all those things are done dynamically. That's the best advantage that you get going through Spark Databricks. Again, internally it uses the same technology.
Yeah.
What is the key value proposition of ML in Azure? So Azure, came up with we used to have something called ML Studio that is more of actually we still have it. It's just more of a drag and drop. You don't need to be a data scientist and data engineer. The core tech skills that you need to know, science skills that you need to know. It was more of a drag and drop, like you get the data, source the data, you do a split for train and test, and you choose the machine learning algorithm that are available on the dashboard and see how it performs, do a cross validations and all those things. But now we have end-to-end comprehensive ML services. It used to be called ML Workbench. Now it is called ML Services that provides you a scripting capabilities as well. Like, you can connect your Spark cluster and get the data, and you can use Python or Scala or R. So all those languages that are very closer to doing data science capabilities are integrated in the ML services, and it allows you to do manage the workflow for the end-to-end machine learning experiments. So the next question is, if you're looking to learn the Azure platform, where would you first focus?
So I suggest like team to focus on the how to ingest the data. That's the first step in the entire big data platform. How to read the data, and how to read the unstructured data, or how to read the structured data, how to read the data from the different sources like flat files, text files, and put it in the data lake. That's where the first one focus is, like collecting the data, and the next one is like cleaning the data, how to standardize the data, and those kind of stuff. And then after, I will suggest them to go to the transformations where they do the heavy lifting, like aggregating the data and those kind of stuff. And then the fourth one comes is analyzing the data, and how to analyze the data. How that kind of really needs it's a different mindset, like to see how the future looks like, what the customer, you need to think in the customer point of view, what their needs and those kind of stuff. And then it's like visualizing the data. So visualizing data is like a Power BI skill sets where you can create a graphs and those kind of stuff.
Okay, so I'm going back to one of the questions. Actually, I think there was a second part of the question: Cosmos DB and SQL Data Warehouse. Cosmos DB is pretty much is a NoSQL data store, versus SQL Data Warehouse is primarily designed for structured data, where you have the relationship is maintained. For example, when you pull the data from online OLTP systems into a warehouse, when you denormalize it, the typical pattern that you use is that to create a star schema or a snowflake schema, facts and dimensions. To maintain that relationship and provide your insights in terms of creating multiple relationship between the data that you have, which is pretty much applies to a structured data store. And if you want to build the data warehouse on that kind of data, that's when the Azure Data Warehouse is primarily used. But when you look at Cosmos DB, it's more of online real time. I'll give you an example. Like when you go to a shopping cart in any of the e-commerce websites today, that's pretty much used on a store like a Cosmos DB. And of course, there is the caching layer that you can build on top of that, but the user ID, the time maybe, and the SKUs of the products they choose, the quantities and things like that, so that I log out from my mobile device and then I go back to my computer, but the caching, that the data is still there in my cart. So in those kind of scenarios, that Cosmos DB is best used from a key value pair store, or if you are getting in data as a JSON payload, like you have multiple business partners that you are working with, and you are exchanging data between them. It comes in an API through APIs, and it's in a JSON format, and Cosmos DB is the best solution to store that stage that data. So it's kind of it's not structured NoSQL data stores, versus SQL data warehouses for more structured data sets. Okay, how do you differentiate between installing HDP Hortonworks on Azure and HDInsights?
It's the same, but same. Azure provides the same capability. Like you need to go to the Azure and select that. Okay, in the HDInsight is nothing but you can choose what kind of cluster. Like you need a Hadoop cluster or a Spark cluster. You can choose the Spark version. So it's nothing but it's like a like it's like a HDP. You can still see the Ambari view there, like how you see in the HDP. The same thing. Everything is same, but only the thing is that you don't need to manage all this stuff. Like you don't need to worry about your network servers and those kind of stuff. It's ultimately done by the Azure.
Yeah, that's a good point. Like good question actually. So HDInsight is based on Hortonworks HDP for that matter. If you want to do a plain vanilla Hortonworks on Azure, it pretty much has the infrastructure as a service. But if you go for HDInsight, it's a platform as a service. So that's the difference. And if it is an infrastructure as a service, and it's your responsibility to maintain the server and making sure that you patch it up and it's under your full control. But HDInsight is like pretty much background. Everything is managed for us. Can you discuss on any imaging API on Azure? I'm not sure what is that exactly on that question. Image recognition. Okay, so image recognition is pretty much there are technologies like convolutional neural net that are available. It depends on, do you want to pre-train or do you want to do a transfer learning from any of the architecture or the algorithms that are already available. So it's I wouldn't say that it's a Azure service, but you can leverage any of the, for example, like VGG16, VGG19. Those are trained on ImageNet, so you can pretty much use that in Azure ML services in your image detection or localization problems.
I don't see any more questions. We'll keep it open for another minute or so. Is there anyone who has a specific business challenge they would like to address in terms of, again, not the details of the company name or anything of that sort? So if you have any questions about what you're working on and where you see there may be some things that Prabha and can address, that would be great right now. Okay, so the question is, for implementing use cases into Azure IoT platform, where would you suggest focusing on learning first?
See, the IoT scenarios are about real time, and when you talk about real time, the capabilities that you would want for your business on, for example, the temporal windows that you have, and I would ask you to first invest time on understanding those requirements, because that drives the architecture and the design. And the second major pain point or a challenge or an opportunity for that matter is that the cloud connectivity to the IoT devices. And there are many technologies that are available today from edge computing standpoint. Say what kind of protocol that some of the protocols such as MQTT protocols and things like that, or something that you might want to invest on, depending on, like, hey, am I putting my IoT device in my factory, or am I putting my IoT device in an oil refinery in the middle of the ocean, and what kind of connectivity constraints that I need to deal with. So based on that, I think you'd be able to come up with a better design with those, checking on those things. Yeah, so let me lead this question. I have a use case where I'm migrating the data from existing systems like Teradata and Oracle and build a similar in Azure. Is it better to build the same set of tables in Azure SQL Data Warehouse, or using Azure Databricks would be better? How the table created in Azure SQL Data Warehouse and Azure Databricks differ?
Okay, so in this case, like you can, if you're running the already business on the Teradata kind of thing, you can simply use the same thing and build it in the Azure and the data warehouse. That data warehouse is nothing but like it provides the whatever the capabilities that are there in the Teradata, and it can be same in the Azure as well. As when it comes to the Databricks is used for not for the final storage like data warehouse, but it's used for the processing the data. That's where the main difference between the data warehouse and the data warehouse is not like you what for example in the Teradata you have a facts and dimensions. That same thing you can build in the data warehouse, but the processing can still happen in the Databricks and push the data to the data warehouse, Azure SQL data warehouse.
Yeah. So again, if you look at the Hadoop HDFS storage, they are distributed file system management. So the data is stored in files. It could be a Parquet file, it could be text file or Avro files, and again, the choice of what kind of format that you would choose is based on do you want data to be encrypted? Do you want how much you want the compression in the security and the latency? Based on that, you would choose the different types of format within the HDFS file storage systems.
Yeah. So one more thing I want to add is the data in the Azure Data Warehouse. There is no need to insert the data in the SQL tables. Like Azure Data Warehouse provides a capability to connect to the external stores like Datalake or HDFS and block storage. You can still store the files, data in the files, but you can do the like create a tables in the external tables in the Azure Data Warehouse where you can query and do the performance and like joins and those kind of stuff.
We are Starweaver. Education you can bank on. For more information, contact us.